Okay. Assalamualaikum warahmatullahi wabarakatuh. In today's class, we are going to revisit the IP version 4 addressing. If you remember, you have actually went through this in network communication class before. So let's look at this chapter as a refresher. For those of you who did not take because you got credit transfer for NetCom, this is a good time for you to listen and get information. There will be some exercises that we're going to do, and at the end, there will be a pop quiz. So what I would like for you to do is, first thing, take a piece of paper or a few pieces of paper and pencils or pen ready because you're going to do some exercise. Secondly, if you have your calculator in front of you, take that calculator and put it way, way, way away from you because we are not going to be using the calculator. Okay? If you have had experience of using the online subnet calculator and whatnot, please don't. One, it's easy for me to know if you have used that. Secondly, it doesn't help you at all. Using the online calculators is actually slower than you actually doing it on your own without calculators. Okay? So everybody ready? Is there anyone in class? Okie dokie. So IP version 4 addressing. So you're just gonna look at some, should I say, refresher, okay? So IP address is used to identify a host within a network. Same goes, you guys have a name, which I call upon. So your name is to identify yourself. Your metric card is to identify yourself with your name in the whole UTM system, because there might be another Ahmad or Muhammad or Tan or Jack or whatever it is. Okay. So a single IP address for each interface, meaning that here, if you have a PC, there is one interface connected to the internet, and that one interface needs one IP address. It needs a name. Okay. And for a router, which has different subnets on its different interfaces, in this case, this router has 3 interfaces. And for each interface, it is a different subnetwork. So for each of the interface, you need a unique IP address. So for the PC here, 1 interface, 1 IP address. For the router, 3 interfaces, 3 different subnets, 3 different IP addresses. Okay. So IP addresses, IP version 4 addresses are 32-bit longs, and it is written in a way of octets. So there are 4 octets, and every octet is a byte. Okay, so there are 4 octets here. So the IP address 192.164.22.31. Give me 2 seconds, okay? Okay, so come again, the IP address is written in octet form, okay? So it's in the dotted decimal notation. So this is an IP address, 192.64.22.31, and it has 4 octets, and each octet is 8 bits. So 192 is here, 64, 22, 31, okay? For IP addresses, you need to know the 8 bits here. If 2 to the power of 0 is 1, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and then 16, and then 32, 64, 128. Those are the only numbers you need to remember. Okay? After that is just adding a little bit, but those are the basics. A subnet is a group of hosts identified with having the same portion of the network bits in their address. So for example, if you are in your family and you have a family name of, let's say, Tan, right? So everyone in your family has the name Tan. So that puts you guys in the same family, in the same subnet. So that kind of works the same way as IP addresses. We have the network address, and that network address tells you which group you are in. And how do you know how much is given by the subnet mask? So subnet mask is usually what you see when they write the /24. So for example, here, 223.1.1.0/24, what it means is that 24 bits in this IP address gives you the network address, the network portion. the family that they belong to. Okay, so let's look at the network portion and the host portion. So the network portion is indicated by the subnet mask, and it tells you how many bits from the IP address belongs to the network. By belonging to the network, it means you cannot touch it, you cannot change it, you cannot tweak it, you cannot do anything. Okay? So host portions is whatever the remaining bits is. For example, in this IP address, 192.64.22.31/24, the subnet mask is 24. That means 24 bits belongs to the network portion. So the remaining 8 bits, 32 minus 24 will give you 8 bits. The remaining 8 bits is the host portion. When we do subnetting, this part is the part, the host portion part is the part that we tweak, we change, we borrow, anything. But the network portion, we don't touch it. That's why it's in red, means no. So this is a network, okay? This is a local area network. And you see this router, it has 3 interfaces connected to the subnets. There is one subnet over here, another one over there, and another one over here. And these subnets, all of the hosts or devices within that subnet, they have the same subnetwork address. So they belong to that. If you see here, 223, sorry, 8/24, 223, 1.1.1, 223, 1.1.2, 223, 1.1.3. You see that because the subnet address is 223.1.1.0/24, that means 223.1.1 is the family name that every device in here will have. So they would have there and then there. You would see that the family name is exactly the same. Okay? What changes are the bits in the host portion. And those you do not touch. Sorry, those are the ones that changes. So this is one subnet, and if you look at here, this subnetwork has a different family, 223.1.2. So all of them, 223.1.2. And in this subnet, 223.1.3. So a subnet tells you if those devices are within the same network. Again, when you do your network, when you create your network, whether it is in packet tracer or in real life, you need to understand where they sit. For example, if you put this device over here and give it this IP address, okay, for this host over here, you give it 223.1.2.1. This PC cannot go into the internet because it has to go through the gateway. And the gateway says, you are not in my family. What are you doing here? So it doesn't manage this the packets from this host at all. So for it to be in the same subnet, it has to belong to that subnet. Okay, and this is something you have to be very aware of. So this is something we have seen before. How many subnets are there? I said that for every interface of a router, it is one subnet. So you could see here, this router is 1, so this is one subnet. 2, 3, but because this and this is shared, so it is the same. We have 1, 2, 3, 4, 5, and 6 subnets. Now, knowing or being able to identify subnets within a topology is very important. Looking at the topology, you need to know, oh, this is a subnet. That one is a different subnet. So that when you assign the IP addresses for the different subnets, you can assign it correctly. When you assign hosts and their IP addresses and their gateway addresses and their subnet mask, you can actually do it correctly. So in the IP address, right, it is connected to a subnet. And the subnet has a head and a tail. The head is usually what you call the network address, and the tail is what you call the broadcast address. Network address is something that holds all of the different IP addresses within its family. The broadcast address is used to reach everyone within that subnet, within that family. So if I want to send a broadcast to all of the PCs in the subnet, I will use the broadcast address. Everyone in that subnet will get it. Everyone else outside of the subnet will not get it. Okay. So here, because the host portion is 8 bits, you can have up to 256 hosts. 2 to the power 8 is 256, but because every subnet, the first IP address is given to the network as network address, the last IP address is given as the broadcast address, so you always have to minus 2. And when you minus 2 for the network and broadcast, you have, in this case, 254 hosts available, 254 IP addresses available to be assigned to different devices. Okay, so this is what you call usable addresses. It is called usable because you can give it to a device and then they can actually use it to go into the internet and so on. So in this case, because it's 192.168/192.64.2231/24, so you have 254 usable hosts, and the host range is from 192.64.22.1 until 22.254. So 22.1, 22.3, 22.100, 22.111, those all you can assign to a device. So if, for example, let's say I give you a skill-based exam, okay, or a quiz, and I give you an IP address and a subnet mask, and I say, can you get me the network address and the broadcast address? The answer is yes. So there are two ways of doing this, okay? One is assigning all the host portion to zeros. Given an IP address and a subnet mask, when all of the host portion is 0, that will give you the network address. When all of the host portion is 1, that will give you the broadcast address. So in this example, we know there 24 bits belongs to the network, so the host bits is only 8 bits. So all the host bit is 0, this will give you the network address. All host bit is 1, that will give you the broadcast address. Easy peasy, lemon squeezy. Okay? So another way of doing that is using the AND. If you remember from Netcom, if you remember further from logic, you have the AND. 1 and 1 is 1. 1 and 0 is 0. So you AND the IP address to the subnet mask. Now, how do you get from /24 to 255, 255, 2550? Every bit in the network portion, you give it the value of 1. And every bit in the host portion, you give it the value of 0. So network portion, all bits is 1. 1, 1, 1, 1, 1, 1, 1, 8 times gives you 255. So 255, 255, 2550, you AND this together, you get 192.168.10, and this is your network address. Again, the broadcast address is just giving the host portion all 1. So this is quite easy. So one thing that you have to be careful about is not to tweak or change the network portion. So it's always important to understand. So for example, here, if you're given this IP address, okay, 182.126.103.215/30, /30 means 30 bits out of the 32 belongs to the network portion. Only 2 bits belongs to the host portion. If you see here, this line that I drew is the boundary between the network portion and the host portion. And as you see, the host portion has only 2 bits. So when the host portion is all zeros, it will give you the network address, which is this one. When the host portion is all 1, it will give you the broadcast address, which is this one. And the usable address will be the one in between. And in this case, there are only 2 usable IP addresses. So in total, 2 bits gives you 4 addresses, 1 to the network address, 1 to the broadcast address, and 2 to the usable. So what we need to see from this slide is that identify the subnet mask, know the network portion and host portion, find the network address, either by changing it all zeros or using an AND, and then from there you can find the broadcast address and also the usable IP. Then you can use this usable IP to assign it to a device or a router interface. So this is another example. Here, the subnet mask is /16. That means 16 bits belongs to the network portion and another 16 bits belongs to the host portion. Okay, you can AND it to find your network address, or you can put all of the host portion as 0 to give you the network address, and all of the host portion as 1 to give you the broadcast address. And if you see here, the range of usable IP is very, very big. So /16 means you can get 2 to the power of 16 hosts. So 2 to the power of 16 minus 2 will give you how many? You can calculate that one. It doesn't come to me right now. Okay? So now that we know how to get what is an IP address, what it looks like, what is a subnet mask, what the subnet mask is for, so how do we do subnetting? So subnetting can be done two ways. Either all of the subnets have the same size, or the subnets have a variable size. And in reality, you might actually have a combination of these two. Okay, for example, UTM, it divides all of the faculties or all of the schools equally, same size subnet. And then when the School of Computing gets their subnet, they will divide it variably to the different department and labs and research labs and so on. So in reality, both can be used. Okay, so far so good? Everybody okay? All
Yes,
right.
please.
Good. So let's try with an exercise. Now, while I'll do this, you have to take out a piece of paper and do it with me. Okay? So that if you have anything that you don't understand, I have a feeling that most of you would not have a problem with this, but if you do, just ask me so that we can get it out of the way. Later on, when you do DHCP and then when you go and learn NAT and when you go and learn all the other stuff, these are the bases that you need to know and get a hold of. Okay, so if you don't understand anything, just ask me. For those who are in my network communication class, this is exactly the same example. So just refresh you. But please do this without a calculator, right? So let's say there is a company and it is given the network address of this 192.168.1.0/24, and it has 4 departments, and these departments has the need, like R&D needs 50 hosts, sales needs 30 hosts, finance needs 20 hosts, HR needs 10 hosts. So because we can either divide it equally or we can follow the needs variably, so let's focus on dividing it equally first. So we have the network address and we want to divide it into equal size subnets. So in this case, there are 4 departments and we want 4 subnets. So first, you need to understand the difference between the network portion and the host portion. So 24 bits belongs to the network portion, 8 bits belongs to the host portion. Excuse me. Now, once you have identified that, you know you can only play or borrow from this side. No touching the red bits. Okay? So now you have to know how many bits you want to borrow from the host portion. So because there are 4, 1, 2, 3, 4 departments, so you need 4 subnets. So how many bits do you need to borrow? Because we are using the power of 2 to the power of 0, 1, 2, 3, 4, we have to use that as a basis. So 2 to the power of what will give you 4? In this case, x is 2. That means we have to borrow 2 bits. Start again. Sorry about that. Okay, so we need to borrow 2 bits. Let's say, for the sake of discussion, if there are like 8 departments here, so 2 to the power of x will give you 8. What is x? X would be 3, wouldn't it? So that's how you get the number of bits that you need to borrow. So now we know how many bits we need to borrow. We borrow. So when we are doing equal size, meaning that all of the subnets would have the same size, would have the same number of usable IP addresses, we borrow from this end, from the leftmost end of the host portion. So we borrow the 2 bits here, okay? And I made a line here so that once you borrow 2 bits from the host portion, it belongs to the network portion now. Okay, it belongs to the network portion. So here we see that 2 bits, 0, 0 becomes 0, 1, 1, 0, and so on. So once you do that, you borrow these 2 bits, then you put all of the host portion to be, all of the remaining host portion to be 0, that will give you the network address, and all the remaining host portion to be 1, that will give you the broadcast address. And you start doing it for everyone. Now, if you see here, because we have 4 and 2 bits, it will start from 0, 0, 0, 1, 1, 0, 1, 1. Okay, binary. This should be not a problem for you. So this will give you the network address, this will give you the broadcast address, and the first subnet is called subnet 0. The second subnet is called subnet 1, subnet 2, subnet 3, and so on. So for subnet 0, the network address is 192.168.1.0. The broadcast address is 192.168.1.63. Okay. The subnet mask now is /26 because you have borrowed this to become the network portion. So now the subnet mask has 26 bits. So the IP addresses, network addresses will all have /26. Okay. So for the usable address for the subnets, okay, this is what we did already. So for the usable address for, let's say, subnet 0, it is between 192.168.1.1 until just before the broadcast address, which is 192.168.1.0. Now, I prefer that all of my students to do their subnetting this way, because with this way, it helps you not only to check your work, but also to find information easily. For example, if I ask you, what is the broadcast address for subnet 2? You can just find here 192.168.1. This is 128. This is 63. 128 plus 63, that will give you 128 plus 63, that will be 172. So that will give you the broadcast address. Okay, so if I ask you, what is the usable address? Then you can just go in between here. So this way helps you not only to check your work, but also gives you quick answers. Looking at this, you would say, what is the subnet mask for the HR department? It's /24, 5, and 6, so /26. So everything is there and it becomes very easy. So then you take the information and you put it inside this table. Okay, if you notice, this is the table we give you for assessment before. So you just put it in there. So the first subnet 0, the network address, the broadcast address, the usable range of IP addresses, and the subnet mask. So subnet mask can be done in the / form or the dotted decimal. So this is the complete one. Yeah.
Miss, I'm still kind of confused with that /. How do we get that /24 or /26? I'm kind of still confused on that part.
That is given. When you are given the network address, the subnet mask is given to you. So the subnet mask tells you which portion that you cannot touch and which portion you can. So at the beginning of this, you were given the network address and the subnet mask of /24. That means from the address given to you, 24 bits. You see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 24. So this red one is 24. That means that the first 24 bits you cannot change. You can only change the other 8. So where you get the 24, when you apply for a network address, they will give you a network address with the subnet mask. And then you know which one you cannot touch and which one you can. And then only can you use the one that you can to create or to do more subnetting. So when you do subnetting, like for example, in this case, when we do equal size subnetting and you borrow from the host portion, so when you borrow 2 bits from here, these 2 bits now become the network portion. That's why I put a line here. So for the people who are using, in this case, R&D, when they get the network address and they want to further subnet, they cannot touch these 2 bits. Okay, and their subnet mask right now is /26.
Means said that network address portion cannot be touched, right? Doesn't change, right?
No, I say the network portion, not the network address portion. Network address is different. Network portion is different.
Okay. So then, I then means how do that means like each and everyone gets one unique network address, right?
Each IP address, each device, each host gets one unique IP address. Yes, but this is a network address. Okay, network address is the head of the group. So you imagine like this: if you ask me for a network address for this class, so I give you a bag, and the bag is labeled with the network address 192.168. So only the IP address in the bag that you can use for the devices or hosts within your network. You cannot go outside of the bag. Okay, then if you get the bag and then you want to divide it into smaller bags within the group, you can. That is called subnetting, which we are doing right now. Okay.
I'm still a bit clear.
Okay, did you look at the subnetting exercises I gave you?
Yes.
You did? The notes all?
Not all, just some of the exercises.
Okay, don't look at the exercise before you look at the notes. Go back, revisit the notes. Okay, go back, revisit the notes. You do have to understand what it means to be. IP address is what you give a host. Okay, so let's say there is a family, and the father's name is Ahmad, and all of the kids would be Ali bin Ahmad, Anisah bin Ahmad, and Jeffrey bin Ahmad, So the Ahmad is the network address, the head of the network. You cannot suddenly put another device in there, it wouldn't work. So this is the network address given to you. And then after that, you can divide it. Why do you divide into subnets? We divide into subnets, one, for security purposes. In UTM, we have a subnet for lecturers. We have a subnet for labs. We have a subnet for students. Why do we put this aside? Why do we differentiate it? Because we don't want leaking of information to people who are not authorized to do so. One. Secondly, is ease of management. When we do like this, R&D, sales, so when they have things that they just want to pass to sales, everybody else don't have to get it. Only the people from sales will get it. And if you remember, for broadcasting, when you do subnet and you broadcast, it only broadcasts within the subnet. It doesn't go to everyone. So now we have saved the bandwidth of the network. Another reason, again, for management is you can actually have access control list for different subnets. Let's say for student subnet, we say you cannot go to certain, let's say you cannot browse. Okay, so we say that anything that has port 80 or whatever, we will close it for you and those packets will be dropped for this particular subnet of the students. We can do that. Okay, so these are the different ways that the reason and ways that subnet is used. Now, your question seems to be that you are asking me to go to the very beginning again, which I think not appropriate for this class. What I would advise you to do is go back and read some basic knowledge again, go back and revisit that. Look at the notes I gave you for subnetting, because that is like, what is this? And those are the basic knowledge. Look at those again. If you still don't understand, then ask me questions. Okay?
Okay. Yes.
Okay. We do have to catch up, because this is my personal. So I'm moving on. So this is an example that we have done before to divide equally. You have the slides with you. I put it up in e-learning already. This example you can do on your own, and then in the lab class we can discuss about this. Okay. There is even the answers there. So if you're not sure, you can tap that. But right now, let's do this. Okay. You're given an IP address or a network address of 192.168. This should be a network address. You're given the network address of 192.168.1.0/24. Okay. So I'm going to give you 5 minutes to complete everything. No need to do a C because we just did that. Okay. The example is just now is dividing it into 4. But let's try dividing it into 2, 3, and 16. So I'm going to give you 5 minutes to do that, and then you will share what you have. Okay? So 5 minutes beginning now. So how are we doing? Are we done? Anybody wants to share? Okay, working on Subnet 16. Yep. If you are up to 16, just show me the first 4 or the first 6 of the 16 subnets. Don't have to write all 16. Okay? Don't have to write all 16. So who wants to try first? Who wants to show me the 2 equal size subnets? Okay, Ma'an. Okay, hold on. Can you share?
Oh, right. Actually, I wrote it in bigger, so
You wrote it in what?
in physical paper.
Ah, can you just take a picture and share it at the class WhatsApp?
Okay.